Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast, coming to you live from the massive studios here in Raleigh, North Carolina. Just me today. Aaron is out and about doing some things. As you know, we've been doing a bunch of shows around serverless. We're going to get back to sort of the core show here this week, and as you know, we've always been following a lot of the cloud native technologies that are out there. We've done some things with the Cloud Native Computing Foundation, and today we've got a really cool opportunity to talk with some folks that are driving some new technologies, some new projects in the open source space. And so, very excited today to have William Morgan, who is the co-founder and CEO of Buoyant, and also the co-creator of the Linkerd project. So, William, welcome to the show.
Thank you very much, Brian. I'm really happy to be here.
So, give us a little bit of background before we get into the project and Buoyant. Now, give us a little bit of your background, because you come from a pretty interesting place in terms of experience and reason why you're passionate about the Linkerd project.
Yeah, so it all starts really around 2010. So I've been an engineer at a variety of startups for many years. In 2010, I joined a little company called Twitter. Well, it wasn't that little at that point. It was already around 200 folks, maybe half of which was engineering. And it was pretty clear, that Twitter was growing rapidly. And this was also the era, I'm sure you remember this if you were on Twitter back then, but this was the era of the fail whale.
Yeah,
pretty much.
Yeah, back in the day when you could only have like a couple of thousand followers or something like that. And
yeah, that's right. And I think it's pretty remarkable that people loved Twitter so much that even though it was down all the time, kind of the basic requirement for a service is to not be down, people would still use it. And in fact, they'd celebrate it like, it's the old fail whale, let's all have a drink.
Right,
or whatever.
Right.
At least that was on the outside. On the inside, we were struggling. I was there as an infrastructure engineer, and especially 2010, around the time that I started, it was just a crazy time to be there. One of the stories I really like telling is the World Cup that happened that summer, the summer of 2010. A massive Twitter kind of presence. And pretty much every time there was a goal, anytime anyone scored a goal in any game, Twitter would fall over. One-to-one correspondence. So that was, at that point, Twitter was largely built on this monolithic Ruby on Rails architecture, which we lovingly called the monorail. And that was, I think, the tail end of anyone really believing that the monorail was a path forward. We had actually invested, a whole lot of engineering effort in the Ruby VM and making the garbage collector better. But at that point, it was really hard to imagine incremental gains really being able to survive. What we knew was going to be even more growth.
Right. Yeah. And back then, today, people have opinions on Twitter and, where did it go with they're all sort of like financially driven. Back then it was, is this service that, like you said, people really kind of loved, is it going to stand up enough, or, is the internet basically going to break it? So, so interesting. So from out of those learnings and scraped knees and pain and suffering and probably a ton of lessons learned, you and your co-founder decided to create the Linkerd project. Give us some idea of the genesis of where this came from and where you guys have been going with it.
Sure. So my co-founder, Oliver Gold, and I met at Twitter in 2010. We both started that year. And what happened was Twitter moved away over a very painful process of a couple of years, moved away from this monolithic Ruby on Rails architecture into this big, massive, multi-service, hundreds of services, highly distributed infrastructure. And that was not something that companies were really doing at that time. Maybe Google and maybe Facebook, but it wasn't the common thing that it is today. And a lot of the genesis for Buoyant, when Oliver and I left Twitter to start Buoyant, is we knew that, and we saw that other companies were going through the same transformation, and the details were all different. Right? They were using Docker. Twitter never had Docker. They were using Kubernetes. Well, we had Mesos. Mesos was a grad student project that we had to kind of turn into real infrastructure, production-grade infrastructure. They were using all sorts of cool new languages. We were using Scala, and so we were on the JVM. So the details were totally different, but the structure of how they were building their software, what people now call cloud-native architectures, was exactly parallel to what we had seen at Twitter, what we had done at Twitter. Only there was a layer that was missing.
Right.
There's a missing component that was very, very powerful and transformative at Twitter that we didn't see an analogy for, and that was around the communication that was happening between these services. So as you become cloud native, one of the components is the way that you're architecting stuff is through microservices. We didn't have that word at Twitter. No one knew what microservice was. We called it SOA, and we kind of hung our heads in shame because we knew SOA was a bad thing to do, but we were doing it anyways. But when you make that shift architecturally from this one code base into hundreds or thousands of services all talking to each other, that communication now is this very complicated thing that also determines, not only is it complicated and new and we never had to deal with it before, but it determines in a large part the runtime behavior of your application.
Right. And so you guys had some internal services at Twitter that you were using, and then you guys decided, is Linkerd sort of the open source version of kind of exactly what you had internally at Twitter, or modifications based on lessons learned, or what's the kind of where's the genesis of where it was in 10, 11, 12 versus where it is today?
So Twitter had a library called Finagle. And Finagle was the thing that you used as a developer to do service-to-service communication. And Finagle started out as just being kind of this, this very developer-focused thing. Okay, we're in Scala, so we want to do functional programming, right? And we're making all these calls. We're going to call them RPC calls. They're Thrift or HTTP or whatever they are. So we wanted to have this functional programming, library for making RPC calls, and then we could do all our flat maps and joins and cool functional programming stuff. And that's how Finagle kind of started. But after Finagle was there and kind of introduced at every layer of the stack, every service would use a Finagle client to make a call to a destination service that would use a Finagle server to handle that call, and would in turn use Finagle to make a call, on both ends to a downstream service. That prevalence, Finagle itself effectively became this platform. And so when we added features to things at Twitter, we'd add them directly to Finagle. And you as the application developer, as a service owner, you wouldn't know anything. I'm building my photo service and I'm making these calls and I use Finagle and it's this cool library. Under the hood, Finagle would be doing circuit breaking, and it would be doing failure handling and retries, and it would be doing load balancing, and it would take into account the latencies of each of the destination instances, and it would optimize the way that it was picking items from that pool to send requests so that everything would be sped up. So Finagle is doing all this crazy stuff. You as the application developer were totally not exposed to it. So Linkerd, so now leaving the Twitter sphere, Linkerd is built on those same core principles. Finagle is open source, and it's still an actively maintained project. Linkerd is built on the same principles, same ideas, and in some cases the same code. But Linkerd has one very big difference, which is that it's a proxy. So it's not a library; it's a standalone proxy.
Okay. So in that sense, do you think about it? So if you're an application developer, or let's say you're operating, say, the platform that you're running on, do you think about it then as almost like an agent that you install whenever you deploy a new microservice, or is this sort of a sidecar thing, or how does the developer of the application now sort of realize that Linkerd is out there to help it?
Yeah, so our goal with Linkerd is, Finagle had two things. It had this programming model and had this operational model. We've thrown away the programming model.
Okay.
So Linkerd is purely an operational tool, and the goal is that developers actually shouldn't even have to know it's there. It's part of this underlying substrate. So if you as a developer are writing the foo service and you want to talk to the bar service, and you're using HTTP, you should be able to connect to HTTP://bar, and that just transparently have that handled by Linkerd, and Linkerd will figure out what you mean by that service, where it is. It'll send the request. It'll handle any failures. It'll do all this stuff for you.
Okay.
So it's very explicitly this operational tool, which means as like a platform engineer or as a SRE or a DevOps practitioner, you probably care about it. If you're in a pure developer mindset, you shouldn't even have to know about it.
Okay. So then as an operator, so you kind of walked through some things there when you talked about what it does in terms of, it does circuit breakers, which is, kind of a pattern in terms of traffic. If you've got a bunch of services and one of them fails, you don't want the rest of them to fail. But then you also talked about stuff like, load balancing and reachability, which sometimes seem like more of a, layer 4 infrastructure, routing kind of thing. Does it do a little bit of both? I mean, does it have awareness at the application level, but then also is it replacing load balancers, or how does that kind of play out? Yeah,
that's a really good question, and I think it's it can be a little confusing because the features that Linkerd is doing. Those features are analogous in a lot of ways to what's happening underneath the hood, layer 3, layer 4. Okay. So Linkerd assumes that you have your layer 3 and layer 4 network there. And you can send packets from from point A to point B. Of course, there's always going to be failures, and that happens.
Sure.
And Linkerd has to account for that. But it assumes that that's done. And so the level it's operating up one level of abstraction. It's operating at the request level. So, at the TCP level, layer 3, layer 4, we're talking about, we've got a packet and we need to deliver it from this IP address to that IP address. And as part of that delivery, we're probably doing name resolution, so we're doing DNS, and we're doing, error handling. So there's, packet loss or duplicate packets. We're doing flow control. We're doing routing to to actually send this through the physical network. Linkerd is doing the same things, but it's doing them at the request level. So it's doing routing, but it's doing it, on a per request basis. It's doing name resolution, but it's doing it, based on service names rather than on server names. It's like, where is foo? I'll look it up in service discovery. It's doing, failure handling and flow control, but it's up one layer of abstraction.
Okay. And for folks who are listening to this, if they're, driving or running or whatever you're doing, we've got some really good diagrams, because this is probably something that would benefit from a whiteboard. But so there's some good diagrams. We've got links to a bunch of really good blog posts that William's done, and some webinars and stuff. So don't feel like you're missing out on the visual of this. We'll get you up to speed as we go along. So you talk a little bit about, you've got some stuff that you've written lately. You talk about this concept of a service mesh. So Linkerd obviously helping with, interacting, like you said, with services. And then you talk about this concept of a service mesh. What is a service mesh in your perspective, and why is it so important?
So a service mesh, I think, is really fundamentally the thing that we're introducing, right? So Linkerd is a proxy. Okay, we've had network proxies for 30 years, as long as network programming has been around. Maybe that's 40 years by now. It's got a particular feature set that's designed for this internal kind of service-to-service communication that's sometimes called east-to-west communication. But the way that you deploy Linkerd is in this particular model where what you're doing is you're not just like sprinkling proxies around. What you're trying to do, the goal of the service mesh is you want to take this communications layer, right? That's this critical thing that's like defining the runtime behavior of your application, and you want to make it a first-class citizen of your ecosystems. You want to make it a first-class member. It's got a name. You can monitor it. You can manage it. You can control it. That service-to-service communication, if you're not using something like a service mesh, it's something that just kind of happens under the hood, and you don't have a lot of visibility into that. And that's kind of the situation. That's where the analogy breaks down a little bit with TCP, where really the goal of TCP is I want to reliably deliver these packets. The goal of the service mesh is not just we want to reliably deliver these requests through your application topology, but we want to make that whole communication substrate a first-class member of your ecosystem that can be monitored and that can be managed and that can be controlled. So that's really the service mesh idea.
Okay, no, that makes sense. And I know in reading through some of the details on it, it's got an element in there where it's managing, say, security or TLS certificates or some of that as well?
Yeah, that's right. So once you have the service mesh in place, once you have Linkerd deployed and it's handling traffic, the baseline set of things that you want to get out of it is a reliability, right? You want to just have requests be delivered in a reliable way, especially, accounting for some of the trickier bits of distributed systems behavior where, if you are not careful about how you're doing things like retries or timeouts, then it's very easy to have one small problem kind of escalate, cascade, and take down the whole site.
Sure.
So that's a baseline, is reliability. But on top of that, you've got visibility, right? So you've got monitoring because you can understand exactly how traffic is flowing between your services. And then you've got policy. So Linkerd can not only just blindly accept requests and say, yes, I'm going to do my best to deliver it. Yes, sir. It can actually deny a request. When does it want to deny a request? Well, that's kind of up to you. So you can add a layer of policy on top of it that says things like, okay, service A can only talk to service B, or these requests are allowed through, but these ones are not. And you can parameterize that in a variety of ways. Okay. I should put a little asterisk there and say this is an active area of work for us in 2017. So we started with reliability.
Okay.
Right?
Yeah.
You got to get that out. That's kind of the, that's like step one, but you've got to have that. Now we're going to start talking about things like policy.
Gotcha. And Linkerd at this point is basically sort of platform independent, right? It'll run on top of Mesos, on top of Kubernetes, on top of Swarm and some other things like that. I know, just looking through the website and all, there's examples of it running in all of those things. So it's basically kind of platform independent, if you will.
Yeah, that's right. We try and make it as much of a glue layer as possible.
Okay.
In practice, it's often paired with Kubernetes, but it's not. There's nothing about what it does that's really specific to Kubernetes. And the reality is when you're introducing Kubernetes or Mesos or any of these things, that introduction, occasionally you can do it in a greenfield way, but typically you're doing that as, alongside a bunch of existing infrastructure. And so you always have this question of, well, how do I merge these two worlds? How do I run Kubernetes alongside my existing infrastructure that's running on Zookeeper or Consul or something else. Right. So we've really spent a lot of time trying to make Linkerd, agnostic and integrate with everything and just be a glue layer.
Okay. Yeah, and actually that sort of leads me to the next question I was sort of curious about. We get a chance to see a lot of these new projects come out and talk to people. As I'm hearing you explaining this, there's always a little bit of somewhat technology overlap, and sometimes multiple projects come out at the same time. Some of the things we talked about, you see examples of that. So, for example, like the whole Netflix OSS thing has things like circuit breakers and stuff like that's now sort of taken to market as like Spring Cloud and Spring Boot. So it's very specific to the Spring development framework. And then to a certain extent, something on a platform like Kubernetes has service discovery and some concepts built in. How do you explain to people when they're trying to make sense of all these different options that they have, like when Linkerd makes sense, when it sort of complements something else, or when when you might say, well, it depends on your environment if you're looking for more language agnostic or something along those lines?
Yeah, that's a good question. So I think the situations in which Linkerd really does not make sense are if you have a largely monolithic architecture, okay, right? Then there's just not a lot of inter-service communication. Maybe you have, a web tier in front and you've got a database tier and there's like communication across those two hops, but there's not a lot that Linkerd can really do for you in that world.
Sure.
If you're doing in a situation that's doing like batch processing or offline computation where there's not this latency aspect, there's not like this kind of transactional component where we have to get this request done in 500 milliseconds, otherwise, the user walks away and buys something else.
Right.
Then Linkerd doesn't do a lot for you. The situations in which it makes a lot of sense is if you're moving into the cloud native world and like you're starting to wrap stuff up in Docker, you're starting to use Kubernetes or Mesos, and you're starting to build multiple services, and deploy them that way. That's when Linkerd is a really good fit because that's when the service mesh really can add value. Okay. I'll say there's another kind of world in which it may or may not make sense, which is for some of the kind of more well-developed applications out there that already have a lot of this logic encoded, in the application itself. Mm-hmm. So, Twitter uses Finagle everywhere. Okay, well, they may not need Linkerd.
Right.
Netflix uses presumably Hystrix everywhere, so they may not need Linkerd. There's probably still some cases there where if you have a library, it's only usable in the languages that the library is written for. So if you ever the more you move to like a polyglot environment, then I think the less effective the library approach is. Right. But there are very well developed systems that do this all in the application level. And in that case, hey, you've got a working implementation. Like, why introduce something new?
Right. Well, and it does sort of play itself to the idea of why people, want to use open source things. If something is very specific to your environment and you kind of want to get out of the business of maintaining that forever, then there makes sense when the community makes a lot more sense in terms of number of engineers that can help, velocity, all that sort. You're getting a broader set of use cases, so it makes a ton of sense. So the project itself now is at 1.0, which is a big milestone. Congratulations.
Yeah, thank you.
You guys donated it to the CNCF, or it's been adopted as a project within the CNCF. Give us a sense of obviously CNCF is a foundation. You still have a growing community around there. How do you think about how you interact from a community perspective versus sort of what you get out of being visible at a foundation perspective? I mean, do you think about those two things differently, or is there a one thing you expect out of the community? Is it really sort of the engineering side of things, and the community is marketing, or how do people kind of interact between those two things today?
So they've largely been the same thing for us, the community around Linkerd, and I'm very happy that we have a growing community of not only users, but of people who are helping other users and of developers and contributors. I'll just take a moment and say, I think one of the most rewarding, if not the most rewarding thing you can get as an open source, kind of project creator is, well, I'd say the number two most rewarding thing, of course, is adoption.
Sure.
Right? If every time someone uses Linkerd and we find out about it, which often happens, weeks or months later,
right,
it feels good, right? But the number one most rewarding thing is seeing members of the community who become active, become engaged, start writing code to the project or fixing issues or writing documentation or even helping other people, on the Slack or in the discourse forums. That just feels really, really good. That's like the reward. That's a real reward you get, I think, as an open source maintainer.
Right. Yeah, no, that part is very, very cool.
Yeah. So the CNCF aspect, to get back to your question, I think that's largely been an extension of the community, because Linkerd makes sense really in the cloud native context. That's kind of the most obvious use case for it. The CNCF was almost a no-brainer for us, because every other aspect, every other project that's going in there are kind of the fundamental building blocks of doing cloud native software.
Right.
So,
yep.
And we actually integrated with the majority of them anyway. So, we felt right at home. Hey, it was Kubernetes and Prometheus and gRPC and all these things that we already were, by virtue of Linkerd being a glue layer, were kind of part of the Linkerd story.
Okay. So, you're sort of seeing, the CNCF doesn't sort of come out and say, hey, this is our stack. It's not, the LAMP stack of cloud native, but you're seeing those projects tend to sort of lead in their given domain, and you're kind of providing integration between those when it makes sense.
Yeah, I think that's right. I don't want to speak too much for the CNCF. I think they have been careful to not have the blessed stack, because that's kind of a fraught thing to do as a foundation or as a committee.
Right.
You want to let the market kind of decide that. But they've been incredibly supportive, and I think the projects that have joined the CNCF, by and large, have been projects that are really fundamentally a part of people's move to cloud native architectures.
Yep. So I know from a Buoyant perspective, you guys list out some companies that are using Linkerd. We talked a few minutes ago about some of the places where maybe it doesn't make sense. Like you said, it's monolithic applications. Are you seeing in your early adopters some patterns or use cases that are pretty frequent that people are using them for, that others could go, we're struggling with that problem?
Yes. So typically, and now it's just going to sound like I'm kind of repeating myself, but really the adoption has come from folks who are moving on to Kubernetes, moving on to Mesos, moving on to Docker, and are starting to encounter the challenges in running those systems, in high traffic environments or in high reliability contexts for the first time. So companies like PayPal and Monzo, the bank in the UK, that's right, and zoos, are all kind of very payments focused companies where, they may not have the request volume of a company like Twitter, but they really care about those requests because each one represents, money flowing from point A to point B.
Right.
So they've been, so they've been pretty early adopters.
Okay.
Right. But we've seen adoption, at companies kind of spanning verticals. One of our earliest adopters was Houghton Mifflin, the textbook publisher, because they operate a large-scale distributed system, and it's from the market perspective, I'm happy with any of these things, right?
Yeah.
But it's typically it's less about the vertical and more about the tech choices and whether they're building out kind of a cloud native approach.
Right. No, and that makes sense because I think as we look at on a bigger scale where Docker adoption is, Kubernetes adoption, and the things that are building on that, it makes sense that it's not just a web scale specific type of problem. It's anybody now who's dealing with web traffic, spiky traffic. Like you said, they're building distributed systems around payments or whatever might be important to them. That makes a ton of sense. Well, listen, let me sort of wrap it up there. Where's the best place? You guys as a company are obviously, you're growing. What's the best place for people to reach out to you guys, or where might they find you at events, or if they just want to pick your brain about some of these challenges?
So I'll start with events. We will be at GlueCon later this month, and we'll also be at CoreOS Fest with our friends from CoreOS at the beginning of next month. Later on in the year, we will be at the Cloud Native Con, KubeCon, which I believe is happening in Austin.
Yep.
For online stuff, we have a very active Slack channel, slack.linkerd.io. We've just introduced a discourse forum, discourse.linkerd.io. To kind of capture some of the less synchronous communication, because sometimes Slack can be hard.
Right.
And generally, we have a ton of documentation on linkerd.io, and we have a ton of blog posts, especially around kind of the Kubernetes service mesh case. If you search for service mesh or Kubernetes service mesh, you'll find at least 9 or 10 blog posts.
Yeah, there's a good series of those going on right now. So we'll get those linked in the show notes. Well, listen, William, thank you so much for coming on today. Like I said, it's always great to sort of dive a little bit deeper into some of the new technologies that are coming out. And we want to thank you for your time. And folks, for Aaron and for William, thank you for listening today. And we'll talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.